Welcome back, and in the previous few lectures, we saw how to submit a script to the Azure ML environment. It then creates a default Python environment on our local machine using the script run config when we created a new run. And now let's take it to the next level by submitting an entire training experiment that does some prediction. So what I have here is a local training experiment. This is pretty similar to what we did while learning the scikit-learn and its comparison to Azure ML Studio. So let me quickly give an overview of what I have here. So first we import the pandas, read the CSV file from the local directory, and then select the relevant columns from the dataset. Next, we drop all the rows even if a single value is null, just to make it simple for now. Then, as you know, we have to create the dummy variables, and we drop the first column. And similar to edit columns in our train model module, we created the X and Y data frames. Then we split them, bring the logistic regression, train the model, and finally do the scoring and evaluation. Now, I'm going a bit faster here as we have done these steps in the previous lectures. But all of this is happening on our local environment and there is absolutely no interaction with Azure ML. So you may have worked on similar experiment or may even have an existing one. And now when you want to bring it to the Azure ML, you will have to first test it as an Azure ML experiment. So let's see what changes are required for that. So first, there will be two scripts, one for the experiment and one for submitting it to the Azure ML environment, or what we call it as run configuration. That is a kind of default behavior now. Then we need to make changes to the current experiment and import the azureml.core classes for workspace and the run. And once we have imported them, then we need to access the workspace as well as get the context of the run. And once we have done that, then our script that we saw earlier can run and we can then interact with the workspace. And then comes accessing the data, training and scoring the model. And this step I'm listing down just for completeness. The program that we saw earlier is nothing but this step, or I will also call it do your stuff here step. Alright. And then comes the logging of metrics and sending the output to the Azure ML workspace. And let's say we want to log the total number of observations, the confusion matrix, and the accuracy score. Then, as part of the output, we may want to upload the scored dataset with predicted probabilities. So, this score dataset will look similar to the output of the score model module that we used to see in Designer as well as the Classic Studio. Okay, so this will complete the changes to the train experiment script. And now, let's see what changes are required for the submit job or the submit script, or the run configuration. For that, let me go to the spider and then explain it there. Now here, there is only one change and a big one that will be required. So we still need all of these steps. But if we submit it using just these, we may get an error. And can you guess why that will be? The hint is in the environment. Well, because this job with this script config will create a default environment which will have just the Python pandas and few more basic packages, we will get an error. Because now our experiment script requires the scikit-learn as well. Because we are using it for splitting the data for this logistic regression as well as for importing the confusion matrix. So that basically means we need to customize the environment and add the scikit-learn package to the default Azure ML environment. So that by default means we need to import few more azureml.core classes, create the scikit-learn as the dependency for that environment and then register it to our workspace. Only then our experiment script will be able to import the scikit-learn classes and modules. I hope you are now clear on what steps and changes that we need to do to earlier script and the job. Great. So without spending much time here, let's go ahead and do it in Python. See you on the other side and thank you so much for watching. Welcome back, and now let's do the changes to the experiment script that we want to run. So first thing is to import the workspace and the run class. And that will be from azureml.core import workspace with capital W, comma, and run with capital R. Next, let's also access the workspace using config file as ws equals to this class of workspace dot from underscore config with two parentheses. And the path of the config file inside the quotes as dot slash config. And next, we need to get the context of the submit job run as new underscore run equals to the class of run dot get underscore context with two parentheses. That's it. So we can call these initial few statements as the preparation for Azure ML experiment run. And I'm coding them once again, even though we have seen these, is because this is how you will make changes to your existing experiments or existing training scripts. And then this entire script will go under do your stuff here. Alright, and just one more point I want to mention here. We have not imported the data store and dataset classes for now, and that is because we are simply using the local file on my machine. So for now, this is enough to run this experiment in an Azure ML environment using the submit job. But we won't know anything about it until we log the details and send the output. So let me come all the way down, and here let's add the block for logging the metrics. Okay, so let's first log the total number of observation as this object of new underscore run dot log, and within parentheses, first the key within quotes as total observations, comma, and let's now get the length of df as len and df within the parentheses. We have done this numerous times by now. And next, let's log the confusion matrix as new underscore run dot log, and within parentheses, confusion matrix within the quotes, comma, and we have the confusion matrix in this variable called cm. So just mention that after the comma. And next, let's also log the accuracy score as new underscore run dot log, and within the parentheses, score within quotes, comma, and then let's mention this variable of score, which will have the accuracy score stored in it. Great. And now let's upload the score dataset to the AzureML workspace. And now, if you remember from the Classic Studio as well as the designer lectures, the score dataset is a combination of test dataset, which we have in the X test, then the actual status or actual Y, which we have in the Y test, and then we also append the scored probabilities and the scored label to both of these. So let me first do some resetting of the X test and the Y test. By now, you must have guessed it that we need to concatenate these data frames and create a scored dataset. But as we have learned in the lectures for pandas, we need to reset the index when concatenating these data frame, otherwise the output will be very weird. Remember, the X and Y test datasets were created from the train test split, and that's why the index values will not be in the same sequence. So let's reset that for X underscore test. So I'm going to type X underscore test equals to X underscore test once again, dot reset underscore index, and in bracket drop equals to true. And this method of reset underscore index will start the index from 0 and then increment it by 1. Let me copy and paste it for Y underscore test and change the X to Y at both these places. Great. And next, we need to get the scored probabilities, and that is stored in this variable of Y underscore prob. But it does not have the column name. So let me convert that to a data frame with a column name. And for making sure we don't lose the existing data, I'm going to create a new one as Y underscore prob underscore df equals to pd dot data frame with D and F capital, and within the normal parenthesis Y underscore prob, comma, and specify the column name as columns equals to, and within square brackets and within quotes, scored probabilities. That's it. And next, we also need the scored label, which we have in this Y underscore predict variable. The process will be exactly same as this Y underscore prob. So let me copy and paste this line, and then change the Y prob df to Y predict df. Alright, and then also change this Y prob to Y predict. And finally, change the column name to scored label instead of scored probabilities. Great. And now let's create a score dataset from these 4 data frames by concatenating them. And let me call this new concatenated data frame as scored underscore dataset equals to pd dot concat, and within the normal brackets, first the list of data frames to concatenate. So that will be within square brackets X underscore test, comma, Y underscore test, comma, and now the scored label as Y underscore predict underscore df, comma again, and the scored probabilities as Y underscore prob underscore df. Alright, and now we also need to specify the concatenation using columns. So that will be a comma after these square brackets, and then, as you know, axis equals to 1. And let's now save it to the output folder so that it gets picked up and uploaded to the AzureML workspace. So that will be scored underscore dataset dot to underscore CSV, and within parentheses, within quotes, specify the path as dot slash outputs slash loan underscore scored dot CSV. And finally, let's complete the run using new underscore run dot complete with 2 parentheses. Wow. And now we are ready with our training script. And if you have been doing it along with me, please save this script before we proceed to the next one. And let's now change our job or the run configuration script for making changes to the environment. As always, it's a pleasure to teach you. Thanks for watching. Welcome back, and today let's see how we can create the run configuration or the submit job for this training experiment script that we have created. So first, let me copy our earlier job script and paste it in a new file. And then let's make changes to it as we go along. And first, let me make some basic changes to it. So instead of calling this as loan_script, I'm going to rename it as training_script. Then the name of the script will be this file name of 200 space dash space training script.py. Okay, and as we discussed, this will give us an error because this job will create the default Python environment and will not find the sklearn library there. So let's say we want to create a customized environment and we call it myenv. And then we need to specify that as part of this script run config as a parameter. So comma after this script name, and then in the next line, let's provide that as environment equals to myenv. And don't worry about the syntax error that will say we have an undefined myenv. For now, these are the basic changes that we need to do to this script. And now let's create this my environment before the script config. So let me declare that as myenv equals to, and this will be an object of the environment class of AzureML. So that will be environment with a capital E and 2 parentheses. And we can give some name to it as name equals to my environment as one word. But we have not imported this class of environment. So just before this myenv, let me import it as from AzureML.core import environment. Great. And we also need to register this environment with our workspace. Otherwise, we won't have the access to it. So that will be myenv.register and within the parentheses, this workspace of WS. All right. But again, this is the default one. So whenever the script is run and the AzureML starts creating the environment, we need to tell it that please do not finalize the environment before you install certain packages. In simple terms, this is also known as the dependency of the environment or the package without which we cannot create this environment. And now please pay very close attention to the rest of the lectures because it is very easy to get confused from here onwards. All right. And now to specify this dependency, we first need to import a class called Conda dependencies. So let me import that as well as from AzureML.core. And now this class is available under another module called environment inside the core module. So specify that as a dot environment, and this is with a small e as it's a module. And then import Conda with a capital C as this is the class, followed by dependencies with a capital D. And I hope I have spelled dependencies correctly. It appears so. And now from this Conda dependencies class, we need to create an object that will have all the required dependencies. So let's create that object as myenv_dep for dependencies equals to, and this class of Conda dependencies dot create, and within the parentheses, we provide a parameter called Conda_packages equals to, and a list of all the packages that we want as dependencies. So a square bracket for now, as we need to provide that as a list. And for now, we just need one package, that is scikit-learn. So within quotes, scikit-learn. That's it. So this statement will create the dependencies object that we can assign to our environment. So before we assign it, let me run just these 2-3 lines of importing the environment and also creating this object of my environment. And then let's open this object of myenv. And now if you come down a bit, you will see this object of Python over here. And this will specify various Python related attributes required by our my environment. And within that, if you come down further, you will see this Conda_dependencies object, which manages all the applications or environment dependencies for Python. So in simple words, if we need to install scikit-learn in the my environment, we need to initialize this object with the myenv_dep. So let's come back to the code and let's assign it after this myenv creation. And before we register it as myenv dot, and then it was the Python module. So specify that followed by another dot and then the object of Conda_dependencies. Okay, I hope you are clear on the path. And this is equal to this object of myenv_dep. Great. And you could have assigned them straight away, but I prefer to do it step by step so that it is easy for you to learn. And that finally concludes our environment creation and its registration with the workspace. So just to summarize it, we imported these 2 classes of environment and Conda dependencies. We also created this environment and created the dependencies in this myenv_dep. We then assigned this dependency to our environment and then finally registered it. Great. And now we are ready to run this script. But first, let me save it as 200-job. You may see people calling it run configuration and various other names, but I prefer to call it a job because I think that is more appropriate. And now, before we run this job, let me go to the Anaconda environment. And here you will see this earlier default environment that was created during the previous run. And if you click on it and search for just SCI, you won't find that package here, which proves the point that we needed that dependency and we needed an additional environment. Anyway, let me now go back to the spider. And now let's run this job. So select all the lines from the job and hit Ctrl+ Enter to execute it. It is going to take some time because it will first create a new environment, download and install all the packages, and then run our experiment. If you have submitted it along with me, you may want to take a long break of 10-15 minutes while it is running. But I still suggest keep checking it periodically, and just in case there was some typo or other errors that you may have done unknowingly. And for now, let me end this lecture here and come back once it has finished running it. I am super excited to show you how these metrics were logged and how the experiment run went. Thank you so much for joining me here, and it is always a pleasure to teach you. Have fun! Welcome back, and let's now see what has happened to our experiment run. So simply go to the AzureML Studio, and within that, the experiment. And here we have this experiment of training script with the latest run as 1. Click on it. And there you go. If everything has gone well, you will see this run 1 as completed and various details of when it was created and started and all of that. These details are exactly same as we saw earlier. And if we scroll down a bit, you will also see the new environment name of my environment. Then right over here, you will see the metrics of score, confusion matrix, and the total observations. You can even view them under metrics and also view it as a table. But no matter what we do, the confusion matrix is this array and not in a tabular format that we used to see. And this is not a good presentation of it. So let's keep it aside and we will deal with it very soon. First, let me go to the outputs and logs. And now under the outputs, you will see this dataset of loan_scored.csv. Click on it. And wow, now we have the scored labels and the scored probabilities appended to the earlier test dataset. And we can use it for analyzing the results in the same manner. But again, we have this extra column at the start. And if you have gone through the lectures on pandas, you would know why that is the case. Well, let me park this issue as well. And just one more point I forgot to mention here is if you still have any previous files stored in your output folder, they will also be picked up and uploaded as part of this run. So don't be surprised if you see more than one file under the outputs. Alright, so we have 2 issues to deal with, one for the confusion matrix and the second for this dataset. No problem, I will show you how to take care of it. First, let me go to this text file of 60 control log and open it and come right at the top. And you will see this line that says the environment not found on the target or on the compute target. And then it goes ahead and creates this Conda environment. And now let me go back to the Anaconda Navigator. And under the environments tab, you will see this new one created over here. Remember, the earlier one of DA3E97 was created as a default one. And for this new script, it has created this new environment with the required dependencies. Click on it and search for SCI. And there you go. You will now see the scikit-learn installed in this environment. Great. And I hope that explains how to run a training script or the training experiment using AzureML SDK. In the earlier one, we did some very basic and small steps. But in this one, we ran a full-fledged training experiment all the way from reading the data to publishing the metrics. And if you have been doing it along with me, congratulations on completing another exam objective of running the training experiment in AzureML using the SDK. And now let's take care of the 2 issues of confusion matrix and the additional column of the index. And in the interest of time, please allow me to do that in the next lecture. Thanks for watching. Welcome back. So let's first take care of the index issue, which is very easy to solve. And as you know, all we need to do is add a parameter after this name of the file as index equals to false. And this will make sure that index is not part of the CSV file. And now let's try to solve the confusion matrix problem. If you see the variable explorer, CM is an array. And if we try to display its content on the console by typing CM and hit enter, you will see that it prints it with this array keyword with these values and these D types. And it was exactly same when we viewed it in the AzureML Studio. And that was happening because we were logging it like a normal variable. Now, AzureML has a special method called log confusion matrix for logging the confusion matrix to the workspace. And let me show that in the AzureML documentation first, and then we will code it. Now, this special method has a formal syntax, and we have to log the data in that format. Only then we will see it as a table. So as you can see, it expects the name, value, and the description, which is same as the normal log method, but the value here is expected in a JSON format. And if you come down a bit, this is how the format looks like. So it has a schema type as a key with a value as confusion matrix and its version and then the data dictionary within it. So the class label under this data is nothing but r, yes and no, or 0 and 1. And matrix is the actual confusion matrix as a list. It's not that difficult, and let me copy this first, and then we will modify or customize it to our Python program. And now just before this first log statement, let me paste it, and it won't give you an error at this stage because it is considered as a dictionary. And let's now assign it to a variable just before this first curly bracket as cm_dict equals to, and let me now edit it for indentation to make it a bit more readable. So here we don't touch any of these keys. They are required by AzureML. And even these two values of confusion matrix as well as v1 will remain as it is as of now. Then in these class labels, we can provide our own values. So in this example code, they had a multi-class classification with 4 predicted values. But in our case, we have only 2 of 0 and 1, or you can say n and y. So let me replace these with an n in quotes and then y in quotes and remove everything else. Great, I hope you are still with me. Now, this matrix is expected to be an n-dimensional matrix, or an n-dimensional list, you can say. So if we have 2 predicted classes, it will be a 2 by 2 list. And the method to convert this NumPy array into a multi-dimensional list is known as toList. Let me show that to you on the console here. So simply type cm.toList with 2 parentheses and hit enter. And you will see this array getting converted to the 2D list, which is the same syntax expected by AzureML. So let me get rid of this entire matrix from this dictionary or from this JSON. And instead of that, code the value for this matrix key as cm.toList with 2 parentheses. Just to make sure that we have not made any error here, simply run this cm dictionary. And it went well, and I'm sure our dictionary is now created. So simply type cm_dict on the console and hit enter. Great. And now all the data is in the required format. And now let me modify this statement where we log the confusion matrix to the new method as log_confusion_matrix. And instead of cm, we now use this dictionary of cm_dict. And that is all that is required. Now let me come back to the job that runs this script and select all the lines and then run them. And now it won't take much time because we already have the required environment created for us as part of the previous run. So let me pause the video and come back while it is running. And there you go, we have this new run completed. Click on it to view the details of it. And now first let's go to the metrics tab because you won't see the confusion matrix here. It will simply show it as an AzureML object. To view it, we need to go to the metrics tab and select this radio button of table. And there you go, we have the confusion matrix in this table format with these n's and y's. That is simply awesome. And the fact that this is available for viewing in AzureML Studio means anyone with the access to this workspace can now view the result. Great. And let me now go to the outputs plus logs and click on this loan_scored dataset. Wow, our dataset is now in the exact same format as we wanted. We have these scored probabilities in the end, and before that it is the scored label and the actual label. And that completes these series of lectures for running a real prediction experiment in the AzureML environment using the SDK. I hope you have enjoyed working on it and now ready to run your new, or if you have any previous training scripts that you want to migrate to AzureML, you know how to do it. Simply bring it in under this do your stuff here block, make these changes for AzureML SDK, log and upload any file, and then create a job script to customize your environment. And off you go. You will be able to demonstrate the results of your experiments to anyone in the world with just an internet connection. And moreover, you can also use these templates as boilerplates and modify them if you need to use it in your job as data scientist. I hope you have enjoyed these lectures. Thank you so much for joining me here, and it is always an utmost pleasure to teach you these exciting topics. Have fun! Hello and welcome, and today let's see how we can create a compute cluster using AzureML SDK. And now let me do some recap using AzureML Studio, and then things will be absolutely clear. If you remember when we created the compute cluster using this tab of compute, and then we used to click on compute cluster, and then on this create button to create the compute cluster. We then used to specify the location, which used to be the location of the workspace, then the priority, machine type of CPU or GPU, and for size, we used to have this list of various machine names. And if we select any of these machines and then click on next, we had to specify a name of the cluster. And as you know, the valid characters were letters, digits, and dash. Then we used to specify minimum and maximum number of nodes, idle seconds before scale down, and then under advanced options, we used to have the virtual network and managed identity settings. For now, we are not bothered about those. But remember, the mandatory parameters need to be specified even when we are provisioning a compute cluster using SDK. And these configurations are called as a provisioning configuration. So let's provision a cluster using AzureML SDK in Python. So as you know, we always need this workspace. And next, let's specify the name of the cluster as cluster underscore name equals to, and within quotes, my dash cluster dash 001. So that is my first cluster. All right. And then let's code the provisioning configuration for this cluster. For that, we first need to import a class called AML Compute or Azure Machine Learning Compute. So that will be from azureml.core.compute. And this is the module from where we can import the AML Compute. So import AML Compute with A and C as capital letters. And within this class, we have a method called provisioning configuration. And for using that, we first need to create a provisioning object as, and let me call this object as compute underscore config equals to, and then this class of AML compute dot and a method of provisioning underscore configuration with parenthesis. I hope you are with me so far. And then inside these parentheses, we can specify the virtual machine size using a parameter called VM underscore size equals to, and then those standard D11 or D1, V1, etc. that we saw earlier. So for now, I'm going to specify in all caps standard underscore D11 underscore V2. And we can also specify the maximum number of nodes that we want. So a comma here, and then max underscore nodes equals to 2 for now. And this is the minimum that is required as a provisioning configuration using SDK. Everything else or all the other parameters are either considered at their default values or as none, or they are assumed based on what we select here as the VM size. So the CPU, core, RAM, pricing is all calculated based on this parameter. Now, you must have noticed that when we are using SDK for provisioning the compute clusters, lots of things are assumed as default. That simply means it expects us to know what we are doing. So essentially, Azure expects that we know what this standard DV2 series means, what is its basic configuration of storage, CPU, RAM, and so on. And it also expects that we should know how much it costs per hour. So for that, I suggest you go to this link of a virtual machine in Azure documentation. Then go to instances, and here you will see various types such as general purpose, compute optimized, memory optimized, and so on. Let me expand this memory optimized, and then you will see these different series of machines. So what we had as a standard D11 V2 is basically part of this DV2 series 11 to 15. Click on it, and you will see various technical documentation of that particular series, as well as what kind of processor is used and so on. Then, if you scroll down, we can see this table that summarizes things such as number of CPUs, memory, storage, and so on. Let me scroll down further, where it has this link for pricing calculator. Click on it. Then click on compute, and then the virtual machines. And after a few seconds, you will see a message that the virtual machine has been added. And please don't be shocked. It is not adding the virtual machine to your account. It is simply adding it to the calculator. So scroll down a bit, and you will see this calculation for different instances. So from this instance drop down, let me select the D11 V2. And there you go. It's going to cost me around $0.26 per hour at the time of recording of this video. The reason I'm saying at the time of recording is because they keep changing the prices. It's possible that you will see it slightly lower or very rarely even higher than 0.26. Anyway, that was enough of diversion from provisioning, but I think it is very much required if you're not on free subscription and simply trying to learn these things. Then it is better to simply provision the one with the least cost. Okay, so let me go back to Python and complete rest of our coding there. So now that our provisioning object is ready, let's create a cluster. And for that, we need to use the same class of AML compute dot, and the method to create that is called as create. No prizes for guessing that. And then within the parentheses, we need to specify WS for the workspace, comma, and the name of the cluster as cluster underscore name, comma, and then the configuration as compute underscore config. Let's also collect the output of this execution in an object called cluster and assign this entire statement to it. All right. And now select all the lines and hit Ctrl plus Enter to execute it. It is going to provision it for us, and let's view it using the studio. So let's go there. And as you can see in this video, it won't happen instantly, but for me, due to pausing of the video, you will see this cluster with the name mycluster1 provisioned over here straight away. Click on it. And there you see all the details of this cluster. So if you have been doing it along with me, congratulations on learning how to provision the compute cluster for your Azure machine learning experiment. You can now use it for various experiments and pipeline runs, either using Designer or even for experiments created using SDK. Now, just a word of caution. If you do not plan to use it beyond this lecture, I strongly recommend that you delete this cluster after you are done accessing it and browsing all the details. You can either delete from here or from the compute clusters list page. Compute clusters are among the most expensive resources on any cloud, so please bear that in mind. And if you plan to take a break, then I suggest deleting the entire workspace and any other storage that you may have that you are planning to use only for learning. For now, I'm going to end this lecture here and leave you with your first compute cluster that you have provisioned using the SDK. As always, it's a pleasure to teach you. Thanks for watching and have fun. Hello and welcome. And today we are going to see an important exam skill set of automating the model training process. Now, this skill set has 4 major exam objectives of creating the pipeline using the Azure ML SDK, then passing the data between the steps in a pipeline, followed by running the pipeline, and finally monitoring a pipeline run. In the previous few lectures, we saw how we can run a script in an experiment using this job or another script. We used to create the environment, provide the required run configuration in the form of script run config, and then submit it. Now, this is perfectly fine when everything can be run in one dedicated script. But in real life, that may not be the case, and we may end up running different scripts and different experiments if we cannot automate the script schedule as well as the data flow between the scripts. And that is where we discussed what is known as the pipeline of machine learning experiment. Now, in an automated pipeline, we can do various tasks independently and in different environments with different packages, different virtual machines, and so on. The Azure ML Designer has this functionality built in it. In Designer, we could run different modules with different data stores for reading as well as writing the data, which basically meant we could use any data store supported by the Azure ML service. We could even allocate different compute clusters to different steps. And we actually implemented that in one of the experiments. And now let's see how to achieve the same using Azure ML SDK in Python. It's going to be a bit more complicated than Designer, just because we need to code everything which earlier was available as a drag and drop feature. But don't you worry, let me simplify it for you, and then I'm pretty sure that you would run it like a master. So here we are going to build a 2-step pipeline in SDK. One step for data processing and the second for building and training a model. And that surely means that we need to pass the data processed in this step to the second one for model building. So let's now break down the tasks required into these 2 steps. So the first step will start by first reading the data, and it could be anywhere. It could be in an SQL table or in a big data server or even in a CSV file. And that is why this step is very much required and very important as well. Second is to select or drop the columns or features. So some sort of feature selection we need to do. It could be as simple as selecting the features based on common sense or based on some feature selection technique. Then we would replace the missing values, normalize the numerical feature, and once we are done with the data processing, we can then upload that data using outputs folder. Now, if there are any metrics such as total observations, total missing count, etc., we can log that as the metrics from this step. And finally, we will save the data to some temporary storage or folder and pass on that data to the next step. Then as part of this step, we may first read the data saved in the previous one and split it into train and test. Then we will train and test our model based on this split data, and finally upload the scored labels and scored probabilities as a dataset to outputs and also log the metrics such as confusion matrix and accuracy. Now that also means we will have 2 scripts for these 2 steps. And let's call this as a data prep file and the second as the training file. And they both will be the Python file. Then we also require another Python file for setting up or submitting this pipeline. It will be very similar to our earlier job script that we had. So it will have steps like creating the environment for both the scripts, then creating and assigning the compute clusters. And now remember, the biggest advantage of using such a pipeline, as we discussed earlier, is the ability to create and customize the entire environment for that particular script. So we will see that also, and how we can assign different compute clusters as well. Then we also need some folder or storage to transfer the data between these steps. That will also be provided by this pipeline script or this job script. Then comes the task of defining the pipeline steps, which will essentially mean creating steps and environments for these 2 scripts. It is possible that they may require different packages. So this pipeline job will make sure that we are able to provide the inputs and outputs of these steps as well. Then we will build a pipeline where we can specify different steps in one pipeline. Then we will create and access an experiment, and finally run the pipeline in that experiment. Wow, that is one big list of tasks. But as I always say, we have broken it down to multiple small steps, and as long as we stick to them in letter and spirit, it will be absolutely easy. I don't know whether I have told you this, but I would love to stick to the principle of KISS, which simply means keep it simple, stupid. Alright? And beyond that, it's a matter of simply knowing which class is required for which task and the syntax of using it. And now I am fully charged up and super excited to show this very practical step of Azure Machine Learning using its SDK. So let's go ahead and first build our job and then create the different steps. It's always a pleasure to teach you. As always, thank you so much for joining me here. Hello and welcome. So here we are, and I have already coded some of the things that we require for creating this pipeline job. We know we need to access the workspace, which is what we are doing here. Then we also created one such environment earlier, and we know how to do that. So I'm not going to code these lines again. Then we also saw how to create a compute cluster, and that is precisely what is happening here. And there is just this one additional step which is waiting for completion of the cluster creation. And it is always recommended because we may start accessing it in further steps in the code and it may not be available. So always recommend to wait for completion. You can simply copy and paste these lines from the previous code. And then now let's define our pipeline steps. So let's code the step 1 of data preparation, and let me call it as data prep underscore step. And that is equal to, now we need another class that defines a step, and it is called as Python script step. It's a one word with the P and all these S's capital. And it is called Python script step because it is going to run a Python script. Well, very logical. Anyway, now this is followed by two parentheses, of course, and it will show us this error because we have not imported it. So let me import it as from AzureML dot, and here the module hierarchy is slightly different. We first have the pipeline module followed by a dot and then steps. So that is from AzureML dot pipeline dot steps. And then the keyword of import, and this class of Python script step. Alright, and now let's provide different parameters to this step. First is the name of the step that our experiment and the pipeline run will understand. So let's look at the simple ones or the simple parameters for now, just to build some confidence. So that will be name equals to, and let me call this in quotes 01 space data space preparation. Alright, it's just the name of the step. So whenever we will look at the pipeline run, this step will be having a name as 01 data preparation. Now, as part of running this step, we will be running some script as well. That means we need to provide the script name as well as the source directory over here. So a comma, and in the next line, let me type source underscore directory equals to, and that will be quick as a dot within the quotes. And if you're storing it in some other folder named scripts or something else, then you can provide that relative path over here. All right. Then a comma, and then script underscore name equals to, and for now, let me call it in quotes 220 dash data prep pipeline dot py. You can give any name there. I'm simply giving this name so that the scripts are sorted based on this number. So you will see them sorted as per the lecture sequence. And then comes the next parameter of input. Remember, this is the first step and it will surely consume some dataset. So let me type input equals to, and here we can add more than one dataset. That means a list of datasets. So a square bracket here, and let's provide a dataset as input underscore ds. Okay, but we don't have this dataset yet. I mean, we haven't defined and initialized it before this step. So let's define it after this import statement as input underscore ds equals to the workspace of ws dot datasets dot get, and within parentheses and within quotes, the name of the dataset as defaults. Now, as you would know, this is how we get or access the datasets registered with this workspace. And that simply means I have already uploaded the defaults dataset to the default data store. So you may also want to do that before you run this pipeline. And you can find that dataset as part of the resources from previous lectures or even from this lecture. You can upload it to any data store as long as it is accessible. Okay, then next we need to specify how this input dataset is going to be passed when we run this step. Remember, this pipeline step is going to run under an experiment run. And we'll create a new one for this, but it is always going to run under an experiment. But as you would remember, for these scripts, we will always create a new run object which can access all the artifacts submitted as part of that run. Remember the get underscore context method that we used to have in the experiment scripts? And then when we pass this input dataset using that run, we have an option of passing it by name. So let me code it first, and then you will be able to understand what I'm saying. So here in the inputs, I'm going to add a method after this input underscore ds as a dot followed by as underscore named underscore input, and inside the parenthesis, inside the quotes, raw underscore data. So what is happening here is this input underscore ds is passed as an input to this data prep step. And when this script for data prep wants to access the dataset, it can now do that using this name of raw underscore data. So this raw underscore data will be the key to access this dataset. I hope it is making sense. And even if you don't understand it 100% right now, just hang in there and park it for now. It will be absolutely clear when we actually use that dataset in this script. All right. And then the next parameter is for the outputs that this data prep step will produce. And as part of it, we need to provide the path where it will be stored. So that is, the name of the parameter is outputs equals to, and this is also a list as we may produce more than one output. So inside a square bracket, let me provide a variable name where we are going to store this output data. And let's call it data folder. And now to explain what this variable will contain, let's go to the designer and let me explain from designer perspective so that it is absolutely clear. And here I have created a small pipeline in designer. And then as part of this select columns dataset, I'm simply selecting some columns and then cleaning the missing data as well. In designer, each of these steps are nothing but pipeline steps. So the output of this select columns is an input to this step of clean missing data. And now if we click on select columns and then expand this output settings, and then click on the override button, and then click on this link of set output settings. And here you will see that this output has a name called results underscore dataset. And we can even specify the data store where we can temporarily store this output. And you can choose the default one or even your own data store. And then this step of clean missing data will automatically pick it up from that output data store. Designer is configured in that manner. But when we are creating such a pipeline in the SDK, we should be able to configure and tell the first step where to store its output. And we may even have to tell any subsequent steps from where to pick up the data. And the only way to do that is by using the data store. So this variable of data folder actually should be pointing or referring to some location inside some data store. So let me define this data folder before this step creation as data folder equals to, and now we need to import another class that can help us create an object which will have all the data reference information stored as data folder. And the name of that class is pipeline data with P and D capital and these two parentheses. I hope it is not getting complicated now. And if you're just feeling that, just hang in there and be with me for a few more minutes and things will be absolutely clear. So first, let me import this class as from azureml.pipeline.core import pipeline data. And now, as I mentioned earlier, the object of this pipeline data class creates the data reference for any intermediate data created between the steps. And it requires some data store for that. So the first parameter that this class requires is the name of the data folder where the data will be stored. And let's call it, and within quotes, data folder in small cases, followed by a comma, and then the data store equals to, and now we can specify some data store name here. For now, I'm going to provide the default data store. So that will be ws.get underscore default underscore data store and two parentheses. And now our step would know where to store the data if we pass on this data folder object as outputs. Great. And now let's see another important parameter of creating the pipeline run configuration. But in the interest of time, please allow me to do that in the next lecture. Thanks for watching. Welcome back. And after the outputs, we now need to specify another parameter for run configuration. Once again, to make it simple and easy to understand, let me go back to the designer. So as we know, we can specify the run settings for each of these steps in this pipeline. We can either choose some default compute target or create our own and specify that also. Now here, because everything is closely knit or closely integrated, we don't have to worry about the compute cluster. We don't even have to worry about its environment, its workspace, and so on. Everything is under one group and everything is sorted. But in AzureML SDK, we have to provide all the details as part of the run configuration for this step. And the parameter for that is known as run config as one word, and it expects a run configuration object. And I hope you are not surprised with that name. Anyway, so that will be equal to, and let me specify the name of this object as run underscore config. And once again, we may have to define and initialize it. And I'm deliberately doing some of these things in the reverse manner, as you must have noticed by now, because then we would understand why we coded certain things and why they are required and where they are required. So come up a bit, and just after this compute cluster, let me type run_config equals to, and this will be the object of a class called as run configuration as one word with R and C as capital, followed by two parentheses, of course. And because we have not imported it, it will give us this error. So let's import this as well, as from AzureML dot core dot run config, all in small cases, import run configuration. Okay, but this object currently has all the default attributes. And as part of the pipeline run, we may have to specify the compute cluster as well as the environment required for that step. So for specifying the compute target, we need to type this object of run_config dot target equals to, and then this object of compute_cluster, where we have the object reference for the cluster that we have created here. And similarly, we need to provide the environment for this step as run_config dot environment equals to the object of myenv, which has our registered environment object. Great. So for now, that completes our run configuration for this step. And finally, we just pass one more argument to this script as argument equals to, and in square brackets. And here we are simply passing the data reference of this data folder or the location of this data folder, so that this new script can actually get the true location and we can actually deal with creating the directories and storing the files. And you will see that in action in detail when we go to the script of this pipeline step. So for now, let me pass it as in quotes -- data folder, comma, and then this variable of data folder. Great. And finally, that completes our first pipeline step of data preparation. Fantastic. And now let's create the second step of training the model. Now the step definition, even for training, is pretty much the same as this step. So let me copy the data preparation step and paste it right below it. And now let me change the step variable as train_step. And then let's call the name as 02 train the model. Okay. And then I'm going to save it in the same source directory. So no changes there. Then the script name I'm going to have is 220 space training pipeline dot py. All right. Then the input for this step is nothing but the output from the previous one. So let me change this output to input and remove this input from here. Then for now, this is our final step and it won't produce any output dataset. So we don't need that parameter as well. So simply delete that line. And then for now, I'm going to use the same run configuration as the data preparation step. But if required, you can always create another cluster and then assign it to another run configuration and then use it here for this particular step. We already have too many things to learn here, and just to keep it simple, I have for now kept one cluster. Okay. Then the same data folder path or the location needs to be known to this step as well. And that's why let's pass this argument to training step also. Great. And we are almost done now. We have so far built the environment, provisioned the compute cluster here, created these pipeline steps, and now let's configure the pipeline using these steps and then create a pipeline run. Once again, in the interest of time, please allow me to do that in the next lecture. I am just a second away. Welcome back. And now that we have defined these steps, let's now build a pipeline by combining them. And let me call this as new_pipeline equals to, and we now need a class called pipeline with two parentheses. And let's also import it from AzureML dot pipeline dot core import pipeline. Okay, and we need to provide the workspace where this pipeline will be created. So inside the parenthesis, workspace equals to ws followed by a comma. And then the steps of this pipeline will be another parameter as steps equals to, and let me provide a parameter called steps. And this variable steps is nothing but a list of step names that we have defined earlier. So just before this import, let me define and initialize it as steps equals to, and in square brackets, the first step of data prep underscore step, and make sure the name is correct, including the case, etc. A comma, and then the second step of train underscore step. That's it. And this will create a pipeline in this workspace and with these steps. This is the minimum that is required. And now let's create an experiment and run our pipeline inside that experiment. So for that, we will need the class of experiment. So let me import it from AzureML.core import experiment with a capital E. This we have done earlier as well, and that's why I'm not going in the reverse manner. And then let's create a new experiment as new underscore experiment equals to the class of experiment with 2 parentheses. And then inside that, provide the workspace as workspace equals to ws, comma, and then the name of the experiment as name equals to, and let me call it pipeline exp01. Remember, this will simply create the experiment and not create an experiment run. For the experiment run, we need to submit the experiment. So let's call this run as new underscore pipeline underscore run equals to this experiment object of new underscore experiment dot submit with 2 parentheses. And if you remember, when we ran the script, we used to provide the script config object, and that object used to have the script as well as the run configuration details. But now we are running a pipeline, and that is why we need to provide this pipeline object of new underscore pipeline inside these parentheses. And as we know, this pipeline object has the details of the steps, and every step has the detail of the script, its run configuration, as well as any input or output. Great. So we are almost done now, and we simply need one last sentence of wait for completion. So that will be this new run object as new underscore pipeline underscore run dot wait underscore for underscore completion with 2 parentheses. And this time I'm going to add one more parameter as show underscore output equals to true. And this simply means whether to display the run status on the system output, or in our case, this console over here. That's all that is required for this pipeline job. Great. And if you have been doing it along with me, congratulations on completing your first AzureML script for running a pipeline. I'm sure you are excited, and we have learned lots of new classes and their usage over here. But this is just the job. We still need to create these scripts for data preparation as well as for the model training. So save this file with some name, and let's go ahead and build our data prep and our training scripts. As always, it's a pleasure to teach you. Thank you so much for joining me here. Welcome back. And before we start creating the data prep pipeline, I thought of taking an important detour of command line arguments in Python. Now, these can be very confusing and not so popular among the data scientists. So let's see what are these in simple language. Well, they are, as the name suggests, the arguments given while running the program using the command line interface. I know I'm not helping you much in understanding this. So let's go to the spider and show you what I mean. So here I have this program area-wa.py, and it's a very simple program that has this function of sqarea, which accepts the side and then returns the area of the square. And we are simply printing it here for this value of 20. So if we execute this, it will print the area of the square is 400, which is great. But what if we want this side to be provided by the user? Well, someone would say we can accept it from the user using the input statement as side equals to int, and within parentheses input, another set of parentheses, and then a text within the quotes as please enter the side. And also change this statement to pass this side to the function instead of this hard-coded value of 20. Great. And now if we execute it, we can now provide any value as an argument, and it will then calculate the area. So then, what is this command line argument? Well, let me show you one more way of executing the Python programs. So I have opened the Anaconda prompt or the command line for Anaconda. You can simply search for Anaconda prompt and open it. You can use any other command line execution from where you can run the Python program. And mind you, this may not be possible if you are using just the notebook. So wherever you are, make sure you are in the right directory before you run the program. I'm already in the correct one where this program is stored. So now I can run this same program of area-wa as python space area-wa.py and hit enter. And then it will ask us to provide the side as the input. And let me provide 30 this time. And there you go. It has correctly calculated the area and printed it here. But what if we want to create a fire and forget type of functionality? What I mean by that is, I don't want to provide this input here. As a user, we should be able to provide the input on this command line itself. And when we provide those arguments or inputs on the command line, they are called as command line arguments. I hope that is making some sense now. And let's see very quickly how we can do that in Python. Now, to enable the command line arguments in Python, we need to import a class called argument parser from the argparse module. Let me type it and then it will be clear. So that will be from argparse, and it's a one word, import argument parser. Again, one word, and because it's a class, A and P will be capital. And I'm a bit lazy in typing this argument parser again and again. So let me import it as AP in all caps. And then we need to create an object of this class as, and let me call it parser equals to, and this class of AP with 2 parentheses. Then to add the arguments to this object, we need to use a method as parser dot add underscore argument, and within the parentheses give the name to this argument in quotes dash dash, and let's call it side, and let's also provide its type as type equals to int. So now our script can accept a command line argument called side. But here we have only added the argument. There can be multiple such add argument statements. So we need to parse this object, or in simple words, break it down into multiple arguments. And that is done by a method called parseArgs. So let me collect the output of that method in a variable called args equals to this object of parser dot parse underscore args with 2 parentheses. I know these words can be a bit confusing, and you must be wondering, where are we lost from this area calculation to this parse and args? Well, just hang in there for a few more minutes and it will be absolutely clear. And I also have a very small surprise for you towards the end of the lecture. Okay, so we need to make just one more change to this script, and that is to refer to this side as this container object of args.side, and then remove this input statement from here. Alright, so now wherever the side is there, we are going to refer it from this args.side or this args container. Save it, and let me now show you how we can run this from the command line interface. So here I'm now going to type the same keywords of Python space area dash WA dot PY, and now we can provide the argument of side as space dash dash side space and the value of the side. So let me provide 50 over here and hit enter. There you go, it calculated and printed the area as 2500. I hope you can now understand the difference the command line argument makes in executing the Python programs. And I'm sure you have understood how this code works. But still, many of you must be wondering, what's the big deal? Why do we need to do this, and why do we need to learn this? Well, imagine we have a script that does some data processing, and we need to do the exact same data processing for multiple files. Are you going to write multiple programs just because the file name is different? Well, surely no. Then what we can do is take the file path and the name as an input from the user, and then use it in the program for reading the file. But then, if there are hundreds of files, you would be sitting for hours just entering the file name and the path. In that case, the best way is to accept the file name and its path as a command line argument, and then submitting a batch job with all these different commands. Essentially, these commands will be executing just one program, but they will have these different file names as the arguments. And if you want, you can submit the job overnight and come back in the morning to see the result. And now I'm sure you can see the benefit. Also, many times we need to run a script from another script and may want to pass some information as part of running that script. Even there, we can use the arguments to pass that information. Now, is it sounding familiar? Have we just done that in the previous lecture? Well, absolutely. We are trying to run the data prep and train scripts, which will be essentially submitted on the command line, and we need to pass these inputs and outputs parameters to it. And that's why we had these arguments here. And we are going to use this exact same structure for the argument parser even in our 2 scripts. I hope now we are clear what these arguments are and how they will be used. And I'm sure many of you who did not know about the arguments will now appreciate why I included this particular lecture right here and not in the Python crash course. So let's now go ahead and create the data prep script. I hope this lecture was useful. Thank you so much for joining me here. Welcome back, and now let's create our data prep pipeline. I have kept this pipeline job open for easy reference. As you know, we executed this training script as part of learning the logistic regression in Python. And then we decided to divide it in 2 steps. So first, let me open a new Python file and save it. And make sure you give the exact same name as provided in this pipeline job. And then from this logistic regression script, let's copy and paste the lines starting from this import pandas statement all the way up to this normalization process. Alright, and this entire code will go under the block of do your stuff here. Great, and before this block, we used to have the AzureML specific code of run and workspace. So let me import the run class as from azureml.core import run. And this is followed by the statement to get the run context. So that will be new underscore run equals to, and this class of run dot get underscore context with 2 parentheses. Great. And now, as I told you earlier, this new underscore run object will also have the access to various parameters or objects within the run. So if we want to access the workspace of this run, we can simply do that as ws equals to new underscore run dot experiment dot workspace. Great. Now, while it is okay to get the workspace object from the config file, the way we did it earlier, we should try to avoid it. Because if there are more than one config files, we may get an error if we try to use another workspace by mistake. Also, while writing this pipeline job, if you remember, I told you that we can access this input underscore ds dataset using its name. And that's why we have this method of as named input. So to access that in this data prep script, we can simply refer to it as new underscore run dot input underscore datasets. And this will give us the access to all the input datasets that have been passed to this script as inputs. And then to access the raw data, we need to provide a pair of square brackets and the key of raw underscore data inside the quotes. Okay, but this will be the AzureML's dataset object. And if we want to convert it into a data frame, we know a method called toPandas data frame. So let's convert it by typing a dot after these square brackets, followed by 2 underscore pandas underscore data frame with 2 parentheses. Great. And this is the dataset that we want to use as an input instead of this local defaults.csv file. So now this df will be equal to this input dataset. And we can get rid of this statement of pd.readcsv. I hope you are still with me. We are still reading the defaults file, but now from the dataset that has been set as an input. And because we are referring to df and data prep in all the other statements, I don't think we need any changes to rest of the code as far as the data processing is concerned. Great. So after normalization, we will have the final output in this data prep data frame, which we need to send to the data folder of the default data store. So how do we access the data folder now? Well, I hope you remember the pipeline data reference and how it was passed as an argument. So we have to collect the argument sent from the pipeline job in this script. And because this is our first pipeline, I'm going to go a bit slow here. And some of the smarter folks, please bear with me for that. So to access the argument, let's first import the argument parser as from arg parse import the class of argument parser as a p, same as we did earlier, and then create an object as parser equals to ap with 2 parentheses. And then we need to add the argument as parser dot add underscore argument, and inside the parentheses, inside the quote, as dash dash data folder. Okay, then a comma, and its type will be equal to str for string. Great. So this is simply the directory path sent to this script. Then let's parse the arguments in args equals to parser dot parse underscore args with parentheses. And we know what this does. So the argument of data folder that is passed to this script will now be available in args.data folder. Great. So this argument is basically the location of the data folder. But remember, the actual folder does not exist. We have to create it so that we can save this data prep file over there. So to create or make the folder or directory at that location, we need to import another module called OS. So it is as simple as import OS. And this module provides us the functionality to interact with the operating system, or basically anything that can be done at OS level or anything that is allowed, such as creating a folder or making directories. So then to make the data folder directory, we need to type os dot and the function of make dirs for making the directory, followed by parentheses. And inside these parentheses, we now need to provide the folder that we want to create. So that will be args.data folder, followed by a comma, and then another parameter called exist underscore OK equals to true. So by making this parameter true, we are simply saying that if the folder exists, don't do anything. By default, it is false, and it could give us an error if it exists and we try to create it once again. Alright, and now we can save this data prep as a CSV file using the to_CSV method. So that will be data prep dot to underscore CSV with parenthesis. And now in such scenarios, if we want to save this file using this method at the correct location, then we need the absolute path of the file. And we need to do that at runtime. So there is another method of this OS module that can help us to create that path. And let's do that before this to underscore CSV function as path equals to os.path.join and then provide the args.data folder, which has the path up to the directory, followed by a comma, and then the file name with which we want to save the output. And let's call it defaults underscore prep.csv. And this should be in quotes. So this will join the CSV file name with the directory structure and create an absolute path for us. And now we can provide this path inside this to underscore CSV method of data prep as path followed by a comma and then index equals to false. That's it. And finally, we need to complete the run as new underscore run dot complete with 2 parentheses. And now our data prep pipeline is ready. Wow. I hope the last few minutes were worth the explanation. And considering the wider audience, I thought it would be better to explain every word here and why we are doing it. Next time, for the next script, I will be very much quicker because we have almost done everything that is required for the script changes. So from all practical perspective, this is good enough. But if you want to log the null values, you can very well do that as before. So let me quickly finish it as for column in all underscore calls. And I'm deliberately using a new variable as all calls because we have already used the calls and columns for the object and numerical variables. And then inside this for loop, we can log the values as new underscore run dot log and within the parenthesis column, comma, data null and in square brackets column again. And let's get this all calls initialized right after dropping the ID column as all underscore calls equals to data prep dot columns. That's it. And finally, we are now done with the data prep step. So just make sure everything has been coded correctly. But hang on a minute. I think I made a mistake here. This should be data folder and not the folder. I think I said data folder but typed just folder. I hope you didn't make the same mistake. Great. And now let's move on to create the training pipeline step in the next lecture. As always, thank you so much for joining me here. Hello and welcome. Today, let's complete the training pipeline. And this is going to be super quick because we already know and have done those changes in one script or another. So I'm simply going to walk you through this code. You will surely understand how minimal the changes are for this particular script. So here we are importing the run class as well as the arg parse module. Then similar to all the other scripts, we get the context of the run. And as we did in the data prep pipeline script, here we access the workspace from the new run.experiment.workspace. Great. Then we also have this argument parser code for the data folder. It's exactly same as the data prep script, just that I added it in the beginning itself. And there is a reason for it. And that is because we need to access the data folder as the first step after accessing the workspace. So then we import the OS and pandas modules, join this path of args.data folder with the CSV file name, and then using pd.readcsv, we read the data from this file. Then all these steps are exactly same as we did in the logistic regression as well as in running the training script lecture. So just to recap it, we simply create X and Y, split the data into train and test, train the logistic regression model, and finally predict from the test data as well as create the confusion matrix and the accuracy. Then we log the confusion matrix as well as the total observations and the accuracy. And finally, we upload the scored dataset with the scored label as well as the scored probabilities of the test data. Great. This was pretty quick and rightly so. There is absolutely no change, or I would rather say nothing new here when we compare this script with the data prep script. And I hope you have understood what we have done here. Great. So by now we have coded the job, the data prep script, as well as the training script. So both the steps are ready as well as the job is ready. And in the next lecture, let's now go ahead and run the pipeline using the pipeline job. And I am super excited to show you how the pipeline runs and how we can monitor and visualize different runs using SDK as well as the new studio. As always, thank you so much for joining me here. Welcome back, and I hope you're also done with all the 3 scripts. And before we submit it, I want you to do some basic checks. First, make sure that the workspace is created and is deployed. Then, we are going to use the defaults dataset of this workspace, so make sure that you have created the defaults dataset using the defaults.csv file. And if you create it by uploading the local file using the Web Studio, then you have to be a bit more careful. Because while uploading it towards the end of the dataset creation process, you will see this screen where some of these columns will be converted to Boolean variables. And if you do that, we could face issues while doing the dummy variables. Because remember, we have the dummy variable creation step using pandas. And that is applied only on categorical or object type of columns. So if we convert some of these columns into Boolean and then refer to the yes and no columns, like we did here for y, we will get an error. So before you finalize it, make sure that all such conversions are not done or you skip the data validation step. Great. These are just a couple of points that you should take care of. And now let me select all the lines here and run them using Ctrl+Enter to run our pipeline. Great. The code will start running eventually, and we will start seeing various messages here on the console. Then after a few seconds, when you go to the studio and then the compute clusters and refresh it, you will see that the cluster has been provisioned. Great. So one part of it is successful. Next, let's go to the experiment and see what's going on there. And now here you will see that the pipeline has been created without any latest run because it is still in the process of preparing the environment and Docker preparation. And if we click on this pipeline exp01, you will see 0 runs under it because nothing has been started yet. So I'm going to pause the video and also go to the spider in the meantime to see what messages are being provided. And here it has started execution and a few messages will start flashing on the console, such as it has submitted the pipeline run and the status is now running. But remember, this is for the pipeline experiment run. We will still require some preparation for the data processing step. It will also show us this message that it has started logging to the text file. And finally, it starts provisioning the Docker for our run. And very soon, you will start seeing the messages that it has started the download, various pull and push messages for the Docker files. And now let's go to the studio and see what is happening there. Let me refresh this page. So there you go. The pipeline run has been started. But this is for the pipeline job that we have submitted. The reason I say that is because, and let me first click on it. And there we have our actual pipeline. Now under the graph, you will see both the steps of data preparation as well as the model training over here. Now this defaults dataset has also been added as an input. The first step of data processing is still under the status of preparing for the required environment and Docker images for it. Then we have the output of data folder from the data preparation step, which is consumed by the training step. Then if you click on the steps here, it will show that it has created the 2 steps of data preparation and the train model. In that, the run 2 is nothing but the run for data preparation. It has a status of preparing while the train model has not yet started. It also tells you that it has started on this compute target. And of course, the run ID is mentioned here that has been auto-created. So the run 1 is for the pipeline, within which it has got these 2 child runs. So it has assigned run 2 for the first step. And as this finishes and the train model step starts, you will see this run number as 3. Let me refresh it. And it is still under the preparation stage. Now, if we go to the spider, you will still see the packages getting downloaded and the environment getting created for the data preparation. So let me pause the video as it finishes everything. And now let me go back to the pipeline run and refresh it. And it still says preparing. Let me go to the graph. And you may get confused here that why it says running at one place and preparing at another. Well, this running is for the pipeline, and if we click on the data preparation step or the box, you will see the correct status at both these places. And now the status is changed to queued for execution. Now this has started after almost 11 minutes. Few more minutes and pausing of the video, and the status is now getting finalized. Great. It has completed successfully now, and the train model is now queued and will start running. So the train model is now run 3. Then to see the details of the data preparation step, we simply click on it and then expand this small window here. Great. And you can now see various metrics that we logged for various null values. And we didn't log anything else, and that's why we just have these ones. Then all the other details are exactly same as we saw earlier, such as the compute target, environment, and it even has the arguments that have been passed. And let me check if the train model step is also done. And let's go to its run detail, and you will see exact same format and the details there. And I'm sure you can now figure out the metrics, the output folder, the file that we have uploaded, and many other. This is very similar to any other run. Great. And now, just to summarize it, we have been able to create our own pipeline using this defaults as the input dataset and these two steps. It was passed as an input to the data prep, and finally, we trained the model using this step, which used the output of data prep as an input. So if you have been doing it along with me and also were able to run it, congratulations on creating and running your first pipeline in Azure ML Workspace. As always, a word of caution now. If you are done, at least delete the compute cluster because it is a very expensive resource. Or if you plan to take a long break, then it's always better to delete the entire resource group to avoid any extra costs. And you can always create these things by submitting a simple script that we saw earlier. Once again, congratulations and thank you so much for joining me here. Have fun. Hello and welcome, and today we are going to learn how to use the execute Python script module in the designer. This is also one of the sub-objectives as part of learning the Azure ML designer. I purposely kept it after the Azure ML SDK lectures because it does require the understanding of some Python code as well as the Azure ML SDK. So let's begin by simply dragging and dropping this module on the canvas. Then let me also search for the adult income dataset, and this is the dataset that I have already uploaded to the workspace. Drag and drop it here. And then connect this dataset to one of the first two input nodes. Alright, so as you can see, this module takes 3 inputs and produces 2 outputs. The first 2 input nodes are for accepting the datasets. So something like this adult income dataset. Whereas the third one is for adding a completely customized Python script. Okay? Then if you click on this module, you will see this block of sample code along with all the explanation of this module. Let me click on this edit code button to open this bigger editor. And now let me simply select all these lines and delete them. I mean, there is so much of information text and it can be very confusing at times. Anyway, and now let me simply paste the code that I want to show you. There you go. It is a pretty simple code where I'm importing pandas as PD. Then we have this function of AzureML_main with 2 arguments. And this is a must-to-have line. And I usually prefer not to change this code too much and try to keep it as simple as possible. Later on, I will show you how to include the complex code using this third node for zip files. So here we assign the input data frame of data frame 1 to df. We then drop the 2 columns of fw and edunum from this data frame. We also create 2 datasets of x and y using iloc. And finally, we are returning the x and y. Again, whatever dataset we return here has to be a pandas data frame and not even the series. And that's why you see this y created as -1 and a colon. If you simply give -1 here without the colon, it will create a series and you won't see it as an output of this module. Okay? So 2 must-haves for this module are the AzureML_main function and the return should have a pandas data frame. Great. Now in this designer, let's come down a bit and provide the compute cluster as my cluster 001. I have already created this. You can pause the video and create your own before submitting it. And we are now ready to submit this pipeline run. So hit this button and then for the experiment, let's create a new one as Python-exp001. And hit the submit button again. It should then submit this pipeline run and you will start seeing the notifications here as well as the progress of changing from not started to preparation queued and so on. And as you know, it is going to take some time as it prepares the cluster for running. So I'm going to pause the video and come back once it is completed. It has finished running for me, and to view the output, simply right click on it and visualize the result dataset. There you go. We now have the 12 columns in the first results dataset. And if you remember, the original input dataset had 15 columns. We dropped 2 of fw and edunum, and then we created the x and y. So this one that you see is our x dataset, which has 2 plus 1, which is 3, 15 minus 3, and that's why we have the 12 columns. And if you scroll towards the right, you won't see the 2 dropped columns, as well as the income column. Then click on the result dataset 2, and here you will see our y dataset of income. So that basically means our script here worked perfectly well. Great. And I hope now you know how to use the custom code using the execute Python script module. In the next lecture, let's explore how to use this third node by attaching the input code in a zip file. As always, thank you so much for joining me here. Hello and welcome. So in the previous lecture, we ran this execute Python script module with this small script over here. But remember, this entire thing is nothing but a pipeline. That also means internally, it should follow the exact same structure as this Python pipeline step. So the execute Python script module is nothing but this class and its object of Python script step that we saw during the creation of Python pipelines. And that class had this 220 data prep script, which is nothing but this particular script, except this function over here. Also, the run config of the Python pipeline is pretty much the same as these configuration settings where we provide the compute as well as the output details. Alright? And I'm sure you won't have any problem understanding this if you have done the Azure ML SDK pipeline runs. Great. That also means in this execute Python script module, we should be able to access the run information, workspace, as well as do pretty much everything that we did here in this Python code. We should also be able to access any dataset using this script and not just on the canvas. And yes, that's precisely what I want to show you in this lecture. So we used this adult income as part of the input node here. And now I'm going to show you how to use this third node or the third port for zip script bundle. Now, if you remember, in the Python basics section, I have explained what we mean by modules and how they are nothing but the Python script files stored in some folder. And then we can simply import any of these Python files by using their name and the import keyword. Similarly, if we attach any zip file to this third port of the execute Python script, it will first unzip it during the runtime and store all the Python scripts in a folder or directory called script bundle. And once that has been done, this module will have direct access to these Python files, and we can simply import them as import and the Python file name without the .py extension. That also means we can then use any function within this data prep or any Python file by simply typing module name .function name. Okay? And that's just the theory or how things work when we use the zip port of this execute Python script module. And now let's go ahead and code this using Designer as well as Spider. Thanks for watching. Welcome back. So I have created a new pipeline here and also dragged this execute Python script on the canvas. And let me call this zip file exp. And now let's go to the Spider and see how we can create the zip bundle. So here I have already coded the dataprep.py script. And as you can see, it is pretty much same as the previous dataprep pipeline script. So once again, we import the run class, get the run context, and also access the workspace. Then I have made some slight changes here. I have added all the other steps in this function of data prep. So we simply access the dataset as a data frame, drop a couple of columns, and select only the first 1000 records, and then return this input dataset, which is now a data frame. You can return anything here, and this will be used in the Azure ML _ main function. So it actually won't matter even if we simply return some calculated value or anything of that sort, as long as in the Azure ML main, we return a data frame. I hope this is pretty simple and easy to understand. Then the next step is to create a zip file out of this. So let me just go to the Explorer and right click on this file name and send it to a compressed zip folder. Great. And now let's go to the Azure ML Studio and see how we can import this in a workspace. So first go to the datasets tab and then let's upload the zip file as a dataset and from the local files. And let me call this as data prep. Then this dataset type will be now a file instead of this tabular one. For the normal structured data, we used to give this as a tabular file, but now we will convert that to file. Click on next. Click on browse and select the zip file and open it, and then click on next. Now this will start uploading the file and it should be done pretty quickly. And once we are done, we can then click on create to create our dataset or create our zipped dataset. It should be done pretty soon and you should see a success message. And now let's make use of it by going to this Designer tab. Click on this zip file exp that we created. And now under the datasets, we should be able to see the zip file of data prep. Drag and drop it on the canvas and then attach the output of this zip dataset to the third port or the third node of this execute Python script module. Alright, and then let's click on this module and let me edit the script now and get rid of these comments first. And then in order to make use of the data prep script, I'm simply going to import it inside this Azure ML main function. So that will be import and the file name without the .py extension as data prep with the D and P capital. Now, if you remember, we have a function called data_prep in this module, and we can now access it as data prep dot data_prep with 2 parentheses. Okay? And because this function returns the process data in a data frame, we should accept it in a variable called df equals to and this statement. And now let's return this df instead of the data frame 1. That's it. And now if you look at this code, it is pretty neat and clean. All the heavy lifting has been done in this data prep script bundle. And another point I want to mention here is that we can have multiple Python scripts inside this bundle that is inside this bundled zip file. And that is precisely the reason why it has been provided as a zip file. At the runtime, all of them will be placed under the scripts bundle directory. And then we can simply import them in this AzureML main function and make use of their functionality. And that will provide you huge amount of flexibility, and you can make the best of both, the Visual Designer as well as the flexible Python scripts. Great. Also, make sure you have the compute target created and attached as part of the run settings. And if everything is ready, simply submit this designer pipeline with execute Python script. And I'm going to use the same experiment as before, and then submit it again. It's going to take some time, so let me pause the video and come back to you once it is done. There you go, it has finished running successfully, and I am so excited to show the output to you. So right-click on this module and then visualize the result dataset. Wow, it now has the first 1000 records and only 13 columns compared to the 15 that we have in the original dataset. Isn't it amazing to see these results? So now you can create your pipeline using the designer, and whenever you need a little bit more flexibility, you can always bring in this module and attach your small scripts there. You can use it for dropping or adding features, creating some custom columns based on certain calculations, or maybe just create certain values over there. The possibilities are endless. Great. And now that also brings us to the end of this lecture, and I am so happy to teach you Azure Machine Learning. As always, thank you so much for joining me here. Have a great time.